Welcome everyone. So today we'll learn about spectroscopic notation. So it is a standard way to write down the angular momentum quantum numbers. The general expression for spectroscopic notation is 2s plus 1 n Lj. Here n is this principal quantum number, L is the orbital quantum number, S is the spin quantum number, and J is total quantum number. So now we need to consider the electronic configurations, and from the last electron we can get the information about n, L, S and J values, and once we get those values we need to put those values on this general expression and it will give us the spectroscopic notation. We'll consider some examples based on this type of problems. So now we'll consider some examples, and first we'll talk about lithium. So the electronic configuration of lithium is 1s2, 2s1. So you need to focus on the last electron. So here it is 2s1, that means the value of L is 0 and S is half, and J can take values from L plus S, mod value of L plus S to mod value of L minus S. So since L equals to 0 here and S equals to half, so J, the value of J is half, and now we need to consider the general expression for spectroscopic notation, which is 2s plus 1 Lj. So we need to put the value of S here and the value of J here, and we need to consider the value of L, which is 0 here. So now the spectroscopic notation for lithium will be 2s half, because if you put S equals to half it will be 2s plus 1, that is 2, and the value of L is S, 0, that means it is S, and J is half. So the spectroscopic notation for lithium will be 2s half. Now let's talk about boron. So first we need to consider the electronic configuration of boron, that is 1s2, 2s2, 2p1, and you need to focus on the last electron. So here the value of L is 1, S equals to half, so J can take values half and 3 by 2, that means 1 by 2 and 3 by 2. Now if we put these values of L and S on the general expression, we will get these two terms, that is 2p half and 2p 3 by 2, because here the J have two values, 1 by 2 and 3 by 2. So now put these values here on the general expression, and since S is half, so it will be 2s plus 1, that is 2. So these are the two expressions for boron. So I think now you have learned how to write spectroscopic notations, and on our next class we will talk about LS coupling and JJ coupling. Thank you everyone.